Okay, guys, we're going to keep going with properties of real numbers, just like we did on that first day of school. First thing we're going to do is kind of do a little bit of comparing. So we're going to graph these on a number line. Given these three numbers here, how would we plot those on a number line? And if you look at what we have, negative 5 over 2, that's a negative 2.5 essentially. The square root of 2, if you plug that into your calculator, that's 1.41 about, and then we have 2.66. So we're ranging from almost negative 3 to positive 3. So you want to we'll stick 0 in the middle here, and then 1, 2, 3, and then negative 1, negative 2, and negative 3, like that. And then we're just going to plot. So number sense, do you know where this falls on a number line? So negative 5 over 2, and you want to write them as the number they gave you, not as the decimal you turned it into. So negative 5 over 2, or negative 2.5, would be perfectly between, right in the middle of negative 2 and negative 3 here. So this would be negative 5 halves for that point. The square root of 2 is 1.4, so if you think about that, you're not quite halfway between 1 and 2, you're a little below that. We'll put it right about here. That point would be rad 2. And then the last one, 2.667, would be 2/3 of the way past 2, close to 3. So maybe right about there. And that one we will call 2.667. Okay. Example 2, you're doing the same thing, just with different numbers. So negative 1.44444 keeps going. The square root of 3, if you plug that into a calculator, the square root of 3 is 1.732. And then 1/3, you probably already know, is 0.3 repeating, so 0.33333. And then we're going to plot those. So we have, if we put 0 somewhere in the middle here again, we only go up to, not even up to 2. So here's 1, here's 2. And then negative 1, negative 2 is really all the farther we have to go to make it fit. So if we go to plot these, let's start with negative 1.44444, 1.4 repeating. Negative 1.4, it's tempting to want to put that over here somewhere because negative 1 is here, and we always think, well, 1.4 is more than that. But in the negative realm, that's not what we want to do. Let's get this out of here. Negative 1.444 is almost halfway between the negative 1 and negative 2. So that would be this point right here. I'm just going to do the repeating bar on that one. The square root of 3, or 1.732. So between 1 and 2, closer to the 2, it's about 3/4 of the way, right? 3/4 is 0.75. So that would be right about there. And we write that as the square root of 3. And then 1/3. So 1/3 of the way between 0 and 1 would be right about there. Okay. Then we get to example 3. And example 3 just wants you to compare two numbers. And you can plug this into a calculator. The square root of 17, you would get, I don't even know what that came out to, and I didn't plug it into my calculator. Let's see. Square root of 17 is 4.123. But another way that you can think of this is the square root of 17 is a little bit bigger than the square root of 16, and the square root of 16 is 4. So I know that this number is bigger than 4. I know that this number is smaller than 4. So that means that I would put the less than symbol, that the square root of 17 is the bigger value. Okay. Letter B here, if we look at the square root or negative square root of 26, that's going to be a negative 5.099 approximately. Okay, and now think about this. On a number line, if this is negative 5, negative 6 is to the left of that. It's less than the negative 5. So if I'm at negative 5 and then go to negative 6.25, that negative 5, even though it looks like a smaller number as a positive, it is a bigger number as a negative. So that would be a greater than symbol for that one. Okay, some properties. So this chart we are doing properties of addition and properties of multiplication. They're very similar typically, but not the same thing, and sometimes they are actually fairly different. So the first one is maybe one that you haven't done much with. I'm sure you've heard of the other 5 properties that we have there, but maybe you haven't heard of closure. We don't do a lot with it. What it says is A plus B is a real number. So if I have a real number A and a real number B and I add them together, I'm going to get a real number back. And the same goes for multiplication. If A and B are both real numbers and I multiply them, A times B is going to be a real number also. Okay. Then we have the commutative property. And what I always say for this one is think about a commute, right? If you are at home and you commute to school, and then you're at school and you commute back to home, did your distance from school to home and home to school change? If you take the exact same route, it shouldn't, right? So the commutative property says if I do A plus B, it should equal the same thing as B plus A. Okay. I'll show you an example of this later, but it could look something like this. 7 plus 6 plus 9 equals 6 plus 7 plus 9, right? We just switched the order of our 6 and 7 there. Same goes for multiplication. If I do A times B, it will equal the same thing as B times A. Okay, so that's the commutative property of addition versus multiplication. Then we have the associative property, and the associative property always has parentheses involved. If you do A plus B plus C, that will equal A plus B plus C. Okay, so what's happening is you're just taking your parentheses and moving them around a different set of numbers. So you're changing the order in which you add them, but because it's all addition, it doesn't change anything. Now, that doesn't work with subtraction, right? That would change a subtraction problem. It doesn't change an addition problem with the parentheses. It doesn't always change subtraction either, but a lot of times. Okay, so multiplication then, if I do A times B times C, that's the same as if I do A times B times C. Okay, so that's the associative property of addition and the associative property of multiplication. And then the identity property, I always say with this one, your identity, who you are, we don't typically want that to change. I mean, hopefully we don't. Hopefully we like who we are in Christ and we want our identity in Him to stay the same, right? So our identity, in order to not change it, if I'm going to add something, I would have to add 0 so that I am still A, right? A plus 0 is still going to get me A back. With multiplication, that's different. It's not 0. If I multiply by 0, I get 0. So if I want the A to stay the same, I need to multiply by, you guessed it, a 1. So A times 1 equals A. All right, then we have the inverse property, and your inverse is like saying the opposite. Your additive inverse is the opposite number. So if I have A, the inverse would be a negative A. And what happens when I do A plus negative A? I get 0. Okay, so that's the inverse property of addition. When you add the opposite, you get 0. The inverse property of multiplication is different than that. Now we're multiplying by something. What we're doing is we're taking, it's called the multiplicative inverse now. So a multiplicative inverse is a reciprocal. So if I have A and I multiply by the reciprocal, which would be 1 over A, what am I going to get? It would be 1, right? Think of that. If I multiply across, I end up with A over A, and any number divided by itself is 1. Okay, now the only rule with this one is A can't equal 0. And does anyone see why? If I divide by 0, it's no go, no good. You can't do that, okay? So as long as A isn't 0, then that property will work. All right, last property, and then I will show you a few of them. This is the distributive property. You did this a ton in Algebra 1, and you even did it quite a bit in geometry, for that matter. But here's how the distributive property goes. You do A times B plus C, okay? And that will become, and remember this, I always do it with these little arrow guys, A times B, and then your operation stays the same, plus A times C. Okay, so those are all the properties that we're going to be talking about. I'm just going to show you an example here and talk you through what these properties are then. So letter A, negative 2/3 times a negative 3/2. Okay, so it's the reciprocal. Do you remember what that one is? You're right. It's the inverse property. Inverse property of, this would be multiplication. And you can just do an X for multiplication, that's fine. Letter B. Now notice there are parentheses in all of these. Don't let those parentheses take you straight to the associative property every time. I feel like that's tempting to do, but it's not. If you look here, 3 times 4, now it's 4 times 3. Both of them are times 5. We just switched, right? This is from school to home, and from home to school is my example that I gave you. So this is actually the commutative, that's not an M, commutative property of multiplication. Okay. Next one, if you look from here to here, we had 3 times G plus H. Now we have 3G plus 3H. So notice what happened. We multiplied that 3 by both of those things. That is the distributive property. Okay, and last but not least, if you look at this one, the order is the same, A4A3, A4A3. Our parentheses just moved, and when that is the case, when the parentheses are just around a different set of numbers, that is the associative property. And this is the associative property of addition. Okay, or you can say of addition that way. That's it. That is 1 2B. Enjoy.